Here we're going to look at how you can use the data structure a stack to do a depth first search and use a queue data structure to do a breadth first search. In a previous video, you traced through what tree would be created by the following code, and that tree is shown on the top right. And what I want you to do is I've got code here that's going to traverse through the binary search tree, and you can see that I push things onto the stack. Here I also push on the left and right subtree, and then eventually I'm popping things off the stack and printing them if they're not null. So I want you to trace through this code to try and see in what order would the keys be printed. I've got another one for you, which is you're going to work with a queue. So instead of having a stack, I've got a queue. Instead of pushing things, I add them here. And instead of popping them, I remove them, which is also typically referred to as dequeuing. One more, I also have one that uses explicit recursion. So it's not using an explicit data structure of a stack or a queue. So it's really using the implicit data structure that is our stack frames that we work with when we make recursive calls. And I want you to trace through the order in which the nodes will be printed here. So in general, you're filling out what's the order that these keys get printed for stack, queue, and then the call stack or that recursion one. And you can pause it on this slide or go back earlier in the video to see the full code. So here are the 3 things that you're tracing. And you should pause it here, but I'll keep going. Okay, so here I'm going to trace through the code that uses a stack. So the first thing I do is I push on my root node. So that's my 8, so I'm going to add that to my stack. And you can think about my stack as having an item in it that has a reference to that node. Okay, so while the stack is not empty, I'm going to pop the top thing on the stack. If the popped thing is not null, then I'm going to print out that popped thing, and I'll just print out the things by laying them on the top here. So that's what I'm printing. So I'm printing out that popped thing, and then I'm pushing the right tree and the left tree. So I push first the right tree of that popped node and then the left tree. Okay, now while the stack is not empty, I'm going to pop the top thing off the stack. It's not null, so I'm going to print it, and then I push its right and left tree. So I had a reference to that 3, so I push its right and left tree, and in that order. Okay, now while the stack is not empty, I'm going to pop the top thing off the stack. I'm going to print it, and then I push its left and right children. Its right subtree was null, so I'll push a null onto my stack, and its left subtree was null, so I'll push another null onto my stack. Okay, while the stack is not empty, I pop the top thing off. If it's not null, it is null, so I don't print it. Okay, then I go back to the while loop. While the stack is not empty, I pop the top thing off. If that popped thing is not null, then I print it. Okay, but it is null, so I don't print it. Okay, back to the top. While the stack is not empty, I'm going to pop something off of it. So I pop the 6 off. It's not null, so I'm going to print it. And then I'm going to push on its right child and then its left child. Okay, back to the top with the while loop. While the stack is not empty, I'm going to pop off the top thing. I'm going to print it if it's not null. And then I'm going to push on its left and right child. Sorry, its right child, which is null. And then its left child, which is also null. While the stack is not empty, I'm going to pop off the top thing. If it's not null, I'll print it. It is null, so I keep going. While the stack is not empty, I pop off the top thing. If it's not null, I print it. Oh, but it is null, so I don't do that. While the stack is not empty, I pop off the top thing on the stack. That's the 7. It's not null, so I'm going to print it. Then I'm going to push its right subtree. That's null. And then I'm going to push its left tree. That's also null. Then while the stack is not empty, I'm going to pop off the top thing. If it's not null, I print it. It is null, so I don't print it. While the stack is not empty, I pop off the top thing. If it's not null, I print it. This one is null, so I don't print it. While the stack is not empty, I pop off the top thing. It's not null, so I'm going to print it. And then I'm going to add its right and left subtrees. So its right subtree is a reference to that node 14, and its left subtree is null. While the stack is not empty, I pop off the top thing on the stack. If it's not null, I print it. This one is null, so I don't print it. While the stack is not empty, I pop off the top thing on the stack. It's not null, so I print it. And I add its right subtree, and I add its left subtree. While the stack is not empty, I pop off the top thing. It's not null, so I'm going to print it. And then I'm going to add its right child. 13's right child is null, and its left child. 13's left child is null. While the stack is not empty, I'm going to pop off the top thing. If it's not null, I'll print it. This one is null. While the stack is not empty,
I'm gonna pop off the top thing. If it's not null, I'll print it. This one was null. While the stack is not empty, I'm gonna pop off the top thing. If that thing isn't null, then I'll print it. This one is null, so I won't print it. Okay, while the stack is not empty, oh, the stack is empty and I'm done. And you can see I printed 8, 3, 1, 6, 4, 7, 10, 14, 13. When I use a stack, I get what's called a depth first traversal. Okay, now I'm gonna traverse my tree using a queue. The first thing I do is I add the root node of my tree to my queue. So I'm gonna add that, or in-queue it, and I'll represent my queue down here. And so that 8 there is showing that I have a reference to that root node inside my queue. Okay, so while the queue is not empty, I'm gonna dequeue a node. So I'll remove it. If it's not null, I'm gonna print it. And then I'm gonna add its right child to the queue and its left child to the queue. While the queue is not empty, I'm gonna dequeue a node. I'll remove a node. If it's not null, I'm gonna print it. And then I'm gonna in-queue its right child. So that's the 14. And it's also its left subtree. That's gonna be null because 10's left subtree was null. Okay, while my queue is not empty, I'm gonna remove or dequeue the first node. If it's not null, I'll print it. And then I'll add on to the queue its right subtree and its left subtree. And I'm just gonna scoot these down. Okay, while my queue is not empty, I'm gonna remove or dequeue the first node. If it's not null, I'm gonna print it. And then I'm gonna add its right subtree, which is null, to the queue. And I'm gonna add its left subtree, which is 13, to the queue. While the queue is not empty, I'm gonna dequeue or remove the first node. If it's not null, I would print it, but it is null, so I won't print it. While the queue is not empty, I'm gonna remove or dequeue the first node. If it's not null, I'll print it, so I print that. And then I'm gonna in-queue its right and left subtree. And to make room for those, I'll scoot these all down. Okay, so here I'm in-queuing its right and left subtree. While the queue is not empty, I'm gonna dequeue or remove the first node. Then I'm gonna add its right and left subtrees. Those are both gonna be null. While the queue is not empty, I'm gonna dequeue the first node or remove that first node. If it's not null, I would print it, but this one's null. And again, I'm gonna scoot them all down. Okay, while the queue is not empty, I'm gonna dequeue or remove the first one. It's not null, so I'll print it. And then I'll in-queue its two children, which are null and null. While the queue is not empty, I'm gonna dequeue the first node or remove the first node. It's not null, so I'll print it. And I'll in-queue its two children, which are null and null. Okay, let me scoot things down one more time. Okay, while the queue is not empty, I'm gonna dequeue or remove that first node. It's not null, so I'm gonna print it. And then I'm gonna add its right and left subtree. So its right subtree is null and its left subtree is null. Okay, then I'm just gonna go through all these nulls. While the queue is not empty, I'm gonna dequeue the first node. It's null, so I won't print it. While the queue is not empty, I'm gonna dequeue the first node. It's null, so I won't print it. Yada, 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 yada. I would dequeue each one of these and not print it. And then in the end, you can see I printed the 8, then the 10, then the 3, then the 4, then the 6, 14, 6, 1, 13, 7, 4. So it went across the tree by depth. And so here where we used a queue to traverse our tree, we got a breadth first search. It went row by row. And we added the right subtree and then the left subtree, so we traversed it in that direction. But you can imagine I can switch which order I put those on into the queue, and it would traverse it in the opposite direction.
Okay, so we saw that with the stack we did a depth first search, and with the queue we did a breadth first search. When we used explicit recursion, so we didn't use an explicit data structure, we used an implicit stack, which was the stack frames. The order it's going to print it is actually the exact same order as when we print with the explicit stack. And you might notice here that we were making a recursive call on the left tree first and then the right tree, whereas in the stack version, we push the right tree and then the left tree. So these ones give us the same print order, and the reason is that the first thing that's done is we execute the code for the left tree. So in the explicit stack, that happens because we push it last, and it's last in, first out. And with our recursive version, by making that recursive call first, we handle the left tree first. but it still has that exact same structure of the stack. But here we have to wait for the left tree recursive call to return before we even make the right tree recursive call, whereas here that right tree was sort of sitting on the stack waiting. So here's our solution for all the print orders. And again, the stack went all the way to the bottom, sort of a depth first traversal, before ever backtracking at all. So it did 8, 3, 1 before coming back to go and explore the right subtree. Whereas when we printed with a queue, it went across. And you can imagine a depth first search on this one, you can picture it going all the way down before coming back up, whereas the breadth first search is going to go across. That's the big picture that we want you to take away. And again, depth first search uses stacks, breadth first search uses queues.